IFR training video, by
Toga thrust.
Arc DME theory. Introduction. Arc DME purpose. Lateral flight path. Anticipation with DME arc. Vertical flight path. Effect of the wind.
Introduction.
We are facing major changes in aviation, mainly in instrument flying. With the growing importance of satellite positioning, old-fashioned navigation and approach techniques will soon become obsolete. What about pilot core competencies? Are we bound to follow the line and nothing more, or should we keep training those procedures and techniques to keep what makes a pilot, mastering? You think right if you are watching this video. Let's train as a pilot. Satellite navigation and approach techniques will be a part of your training.
Arc DME purposes.
The point in performing such maneuver is to switch from a VO radial to another one, or to typically join the beginning of an approach while relying on conventional means of navigation, bearing given by a Vorlog or less commonly by a NDB, and distance by a DME.
Lateral flight path.
Due to human limitations, it is practically impossible to fly at a constant distance from the navaid. For this reason, we will fly several segments around the navaid, maintaining a constant mean distance. The goal is to enter the arc perpendicularly by using anticipation to establish at the desired DME distance. Place the RMI needle at 90 degrees. As soon as the needle will move 10 degrees away from the 90 degrees position, adjust the heading by 20 degrees. Heading correction should be modulated considering the DME reading. If you are too far, turn more than 20 degrees. If you are too close, keep the heading to allow the distance to increase. When approaching the exiting radial, anticipation should be calculated as to establish on this radial. The leading radials depicted on charts is often too early for a light aircraft as it is computed for high-speed jets.
Anticipation with DME arc.
When entering the DME arc, the anticipation for a 90 degrees interception turn is determined by a cross-track distance. Example, if your ground speed is 260 knots, cross-track distance equals 260/200 equals 1.3 nautical miles. When leaving DME arc, the anticipation for a 90 degrees interception turn on the exit radial is determined by an anticipation radial. The leading radial depicted on chart is often too early for a light aircraft. When approaching the exit radial, just apply the interception principles and at 10 degrees from the radial, turn inbound to keep an attack of 30 degrees.
Vertical flight path. While performing the arc, you may need to continue your descent. This descent may be initiated when passing a radial, or you may need to determine by yourself a point of descent, POD, if you must be at a defined altitude during or exiting the arc. Pay attention to the local QNH. When changing the altimeter setting from standard setting, the true altitude may be subsequently different from the pressure altitude. Therefore, descent calculations should be based upon true altitude. Effect of the wind.
Considering the wind is critical when performing a DME arc. As a matter of fact, depending on the entry and exit radial, the wind can completely revert during the arc. This can lead to overshoot of the maximum arc distance, 0.2 nautical miles, and can potentially drive the aircraft outside the protection area. A DME arc is protected 6 miles each side of centerline, 4-mile primary each side of centerline, with a 2-mile secondary each side of those primaries. On each segment, a mean drift must be calculated, and an adapted heading should be adopted to fly a correct track after the heading change. If the drift is not accurate enough and the DME distance still increases or decreases, a 10 degrees heading change should be made to accomplish a corrective action.